Hello there. This is Dr. David Crowler of the Department of Chemistry of Georgia Southern University with another video lecture. So the topic that we're going to cover in this little video today is unit conversions. Actually, this is a two-part video series. In this first video, we're going to talk in general terms about what conversions are and generally talk about kind of what's happening when you're doing a conversion. In the second video, part two, we'll work through a few examples. Example conversions, say between unit systems, within the metric system, and then, an old favorite for all students of science, a real great example is when you're converting between area units. In this slide, I'll start making a few important points, just qualitative things I want to say about the way conversions work. So whenever you're doing a units conversion, really you're not fundamentally changing anything that's physically real or tangible. You do, however, change the way that you talk about it, sort of the language that you'll use to describe the physical thing. I like using the example of this type of physical object. So what word comes to your mind when you look at this object? The word that comes to mind probably depends upon the language that you speak. If you're an English speaking person, you'll use the word house. If you speak French, if you have a French vocabulary, the word maison will come up. Or if you're Spanish speaking, casa. Or if you are Greek, this thing will come to mind. I'm not exactly sure how to say that. I just kind of found that on a Google translation website. But anyway, whether you refer to this real physical object with these different sort of abstract terms, the physical object is always the same. Okay. And so when you're changing the units systems, perhaps you say like the language that you're using to describe physical quantities, you are strongly encouraged to use, it's called the dimensional analysis approach. There's several advantages to that. When you use the systematic and highly organized dimensional analysis approach to conversions, one of the advantages is that you pretty much automatically get a way of seeing if you're doing it properly. For example, when you use dimensional analysis, you have to write down numbers and units. You can't separate the numbers from the units. Okay, so when you're setting up a conversion by dimensional analysis approach, you will see that the units should really behave the way you want them to. You'll see certain units that you want to go away, you'll see them disappear and cancel. You'll know you're on the right track if the units are working out, if you truly are ending up with the final unit that you want to convert to. But conversely, in the same sense, if the units aren't working out, if the units aren't canceling properly, that's a very strong indication that the numbers are going astray as well. When you're doing dimensional analysis approach, you will be basically applying what's called conversion factors. And the conversion factors are always based on statements of equality. Say more about that in the second video. In general terms, you can approach conversion questions with a very firm, systematic, very organized approach. The first thing you should do when you're faced with a conversion problem, you may be sitting there with your textbook open from a physics or chemistry course or some other kind of course, and you've got this conversion problem. So the first thing to do, figure out what is the physical quantity that you're working with. Okay, is it a length or a distance? Is it a mass? Is it a quantity of time or something else? It's very important that you just get a clear picture in your head of what it is. What is a physical quantity that you're talking about? And you should know exactly what are the units that you have at the beginning. And then you should figure out what are the units supposed to be. What units are you converting into? And then it will sort of be natural for you then to know, based on what units you're starting with and what units you're ending with, what conversion factors you need to get from your initial to final unit. And then based on the units that you're starting with and the units that you're going to switching, converting to, you will see what order, it would be sort of logical for you to apply the conversion factors. So in a conceptual way, you can picture the physical quantity that you're starting with in whatever units you are it is in which it is described at the very beginning. And it's kind of like you're going to a final destination in which you've got that physical quantity, but however it's being described in whatever units you're converting. And kind of in the sense that you're going from point A to point B, and you need a way to get from point A to point B. The conversion factors will basically provide the vehicle or the means by which you're going to get from point A to point B. Okay, that brings us to the end of part 1 in this 2-part video series, unit conversions. So in the next video, you will see these fundamental principles of conversions and this systematic approach that I prescribe being applied. You'll see them in action. However, I just wanted to give this first video because I wanted to help some students out there in the world get a stronger conceptual understanding of what basically conversions are and fundamentally what they're doing, like how they work. Because as I've been teaching chemistry, I've seen too many cases, students getting kind of like really confused and sometimes awfully frustrated as they're doing conversion problems. And I want them to have a clear idea of exactly what it is they're doing. Some students really get frustrated. They're crunching numbers and they're trying everything under the sun and still not getting the right answer and getting all frustrated. Really, if they would just step back and really try to get a clear picture of what they're doing first, and maybe take a deep breath if necessary, and then that will really be helpful as they try to solve the problems. So anyway, enough said. Let's move on to part 2. I'll see you there.